Hey everybody, it's Mr. Roy. I'm here to give you a little support on sections 2.2 and 2.3 that we're covering this week. It's the week of April 13th to 17th, I guess 14th to 17th because we had the Monday off. So we're first going to start with section 2.2. I also want to say thanks to those students who submitted some problems from the practice quizzes that I'm going to go over. So the first thing we'll talk about, this is for section 2.2. Let me get my my pencil here, my pen here. So we're looking at section 2.2. And the first thing we're looking at is this thing called factors. So factors are just like parts of a number or an algebraic expression. Basically pieces that can be multiplied with other stuff to get the numbers that we want. So let's say we got the number 12 and the number 16. With those two numbers, there's a lot of things that can divide those numbers evenly. So for example, 1 can divide 12 evenly. 12 divided by 1 is 12. 2 can divide it evenly. 2 divided by 12 is 6. 3 can divide it evenly. 3 divided by 12 was 4, and so on. 4 can divide it evenly. 6 can divide it evenly, and 12 can divide it evenly. And that's it. Those are all the numbers that can divide 12 evenly. Any other number you try and divide 12 by, and you'll get a decimal. For 16, we've got our factors here as well. We've got 1, 2, 4, 8, and 16 are all numbers that can divide 16 evenly. So when we talk about factors that are common, that means factors that both numbers would have. So in this case, 1, 2, and 4 are all factors of both 12 and 16. So we call those common factors. Okay, so that's what that's our first term we want to get used to. Okay, so let's talk about our next term, greatest common factor. So we talked about common factors, now we're looking for the biggest one. Okay, and we'll actually use that kind of previous example again. So the highest number that divides exactly into two or more numbers is our greatest thing for, in this, you could use it for simplifying fractions. We're going to use it for algebraic stuff though, quadratic expressions. So we're looking for the factor that's the biggest, the number that divides all the terms in something evenly, and we want to find the one that does it the biggest. Because 1 would always be a common factor for everything, but we want to see if we can get some bigger ones. So here's an example. It's actually the one we looked at before. We said 12 and 16. So first we found all the factors for each of them, and then we circled the common ones, and then we chose the one that was the greatest. So of all those common factors, 12 and 16 are both divisible by 1, they're both divisible by 2, they're both divisible by 4. So 4 is going to be our greatest common factor. It's the biggest one that's a factor for both of those numbers. Now, greatest common factors don't just have to be numbers, they can also have variables or unknowns in them. They can have an X or a Y or a Q or an R or whatever. So we're going to get into that when we're looking at algebraic stuff. First though, let's stick with numbers for a moment. So common factors for 15, 30, and 105, right? You may want to pause the video here if you feel like breaking down the factors of each of them. Obviously, each of them is divisible by 1 evenly. 15 divided by 1 is 15, 30 divided by 1 is 30, 105 divided by 1 is 105. So they all have a common factor of 1, but I bet if we wrote out all the factors, we could find some that were bigger. So let's have a little look at that. For 15, here are the factors. It's divisible by 1, 3, and 5. And for 30, it's divisible by 1, 2, 3, 5, 6, 10, and 15. And 105, 1, 3, 5, 7, 15, 21, and 35. So we'll have a look there and see if we can come up with the greatest common factor. We see 1 in each of them, 2 of them is only in 1, 3 is in each of them, 5 is in each of them. And so it looks like 5 is going to be our greatest common factor for all these three numbers. So that's a number that we could divide each of those 15, 30, and 105 by. They're all divisible by 5, and so that's our greatest common factor. Okay, so we say, good, greatest common factor is 5 in this case. Now, numbers have factors, right? You can see that here. The two factors for 6, there would also be a 1 in here, but when you multiply something by 1, it doesn't change. So we could write 1 times 2 times 3. All three of those are factors of 6, and in fact that's all the factors of 6. Although 6 actually is also divisible by 6, so you could have a factor of 6 in there, but these are two of the factors. These are two numbers that when you take those two factors and you multiply them together, you get 6. We could also have 1 and 6 are two factors that multiply together to get 6. So when you multiply multiple factors together, you can get your number. But that's not just true for numbers, it's also true for algebra. So here is an algebraic expression. Here's a quadratic. I'm going to circle that in red. Here's our quadratic. It's x squared plus 4x plus 3. Now, x squared plus 4x plus 3, you can actually split that into two pieces that multiply together to equal it. Just like we did with 6. We took two of the factors of 6 that multiply together to give us 6. You can get two of the factors of this thing that multiply together to give you that. So each of these is a factor of this bigger expression. So one of the things we're saying is that this expression, we can divide it evenly by x plus 3. And we can divide it evenly by x plus 1. You might say, I don't even know what that means, dividing it by x plus 3 or x plus 1. But let's back up a little bit and we'll do something that's a little simpler. This is going to be called greatest common factoring, but using some algebra stuff. So let's have a look first at 2y plus 6. Okay, what I want to do is I want to change this expression by pulling out the greatest common factor, so the factor that's the biggest for 2y and for 6. So we can think about what factors those numbers have. And I can think that, okay, 2y is divisible by 1, and it's divisible by 2, and it's divisible by 2y. Those are all the ones I can think of. And 6 is divisible by 1, it's divisible by 2, it's divisible by 3, and it's divisible by 6. So our greatest common factor in there would be 2. They're both divisible by 2. And we could kind of write it like this, right? 2y is 2 times y, and 6 is 2 times 3. So they both can be broken down to have a 2 in them. They're both divisible by 2. Okay, cool. So since they're divisible by 2, that means I can kind of change my expression. I could rewrite my expression like you see here. I could write 2y plus 6 as 2 times y plus 3. Now, if I look at 2 times y plus 3 and I think, oh, let's multiply through the brackets. 2 times y is 2y, 2 times 3 is 6. I can really easily see how by multiplying through the brackets, I would get this expression over here. What we're kind of doing with factoring is we're doing the opposite of that. Instead of multiplying through the brackets, we're dividing things out of our terms. So what I'm thinking here is, if I put a 2 in front and I divide a 2 out of here, I'm just left with a y. And there it is right there. If I put a 2 out front and I divide a 2 out of the 6, I'm just left with 3. 2y divided by 2 is y. 6 divided by 2 is 3. So basically I've sucked that 2 out of this term, and I've sucked the 2 out of here and put that 2 out front. So I've divided it out of each term. I've divided it out of each term and put it out front. This is called common factoring, and we can do this with algebraic expressions to try and make them look a little different or a little simpler, or to find ways to work with them. Common factoring. So that's actually what we always start with. We always look at our expression here, and we look and see if there's anything that is in each of that can be divided each of those terms. And I say, oh, 2. 2 is the greatest common factor that can divide both 2y and can divide 6. 2 can divide both of those things. Okay, so 2y plus 6 has been factored into 2 times y plus 3. So we're going to get into that a little more, but I want to spend a little bit of time now looking at, we're going to do a couple examples here in a minute, but I just want to key in on this key idea that you're used to expanding. That's when you start with an expression like this and you multiply through the brackets and you expand. 2 times y plus 2 times 3 becomes 2y plus 6. But we also have to think about going the other way. And this is where we're going to actually divide things out of those terms. So I'm going to divide this one by 2 2y by 2, and I'm going to divide 6 by 2, and I'm going to pull it out of both of them and put that 2 out front. So you can see how these would be equivalent. So one is called expanding. You're probably pretty used to that. One is called factoring. Factorings are opposite. Instead of multiplying through the brackets, we're dividing things out of each term. Okay, so let's have a look at one that's a little more complicated. 3y squared plus 12y. Now we think, okay, what's something that divides both of them? Well, they both can be divided by 1. Okay, that's fine. That's not really helpful. They're not both divisible by 2 because 3 isn't divisible by 2. I notice they're both of the numbers are divisible by 3. I can divide 3 by 3 and I can divide 12 by 3. Both of those are divisible by 3. Good, so that's a really good start. I can pull a 3 out of each of those terms. But I also notice that both terms have a y in them. I can pull a y out of here, and that'll pull that entire y out. I can divide that entire y out, but I can also divide a y out of here. I'll still be left with one y because it's y squared. So if I divide one of them out, I'll still have one regular y. But both of them have at least one y and can both be divided by that. Okay, so firstly, 3 and 12, they got a common factor of 3. So we could factor it like this, right? We can take that 3 and we can divide it out of there. Oh, I should keep using my same colors here. Let's go back to red. I can take my 3 and I can divide it out of there, and I can take a 3 and divide it out of there. And that's what I end up with. So that is factoring, but it's not enough. Both of these things have a y that we can pull out. We can do better. So they also share that variable y. And so what we want to do is we're also going to divide that out. So 3 and a y makes 3y. We can divide 3y out of each of those terms. So 3y squared, we say, okay, that's 3y squared. That's 3y times y. And 12y is 3y times 4. So I can actually pull out that 3y. So that's what I've done. I've said, okay, I'm going to pull a 3y out of there, and I'm going to pull a 3y out of there. I'm dividing it out and then sticking it out front. So I'm dividing that 3y out of each of those terms. Out of this second term, I'm dividing out a 3 and dividing out a y, leaving us just with 4. And on the first one, I'm dividing out a 3 and dividing out one of those y's, leaving us just with y. Now we can check it if we want by just multiplying through the brackets again. We can say, okay, if I take 3y times y, that's 3y squared. And if I take 3y times 4, that's 12y. Oh yeah, checks out. Okay, makes sense. So this is called common factoring, and we're looking to see how much we can pull out where we can divide the same thing out of each of those terms. So you might have been okay with all of that. That's great. I want to look now at 3 questions that students have provided that they were wondering about. So thank you to those students. They were wondering about these questions. So we say, okay, first one, the area of a rectangular picture frame is represented by, the area is 35x squared plus 90x. You might say, like, why would anyone ever do a picture frame like that? Why wouldn't you just measure it? Well, when companies are actually looking to maximize or minimize the amount of like area in something so they have to use less materials, they would do math like this. So it's not something you like on a random street corner you'd be doing math like this, or in the grocery store, but this is math about maximizing and minimizing profits or materials. So this kind of stuff comes up a lot in maximizing and minimizing things. Okay, so let's have a little look here. I'm just gonna get rid of that. So I'm gonna make a picture frame. I don't really know what the sizes are yet, so I'm just gonna make a rectangle of I don't know, some size. I'll make it kind of like that. And I know that my area is 35x squared plus 90x. So I know that when I remember the formula for area for a rectangle is length times width, right? So if I go, okay, let's get a blue pen here. I'm going to go, okay, the area is length times width. So that means if I multiply two things together and I get 35x squared plus 90x, that means I've got the two right ones. So when the expression is factored fully, The factors are the dimensions of the frame. So I need to factor this fully, and then I'm going to have two algebraic expressions, one for each side. Okay, so I say, all right, I got to factor this. Let's move my picture frame out of the way here for a second. We'll kind of stick it up there in the corner. And let's take my expression and see what I can get out of each one. All right, so we'll go 35x squared plus 90x. Now the first step I want to take here is I got to figure out what are my common factors. What can I pull out of each of these? So I've got that nicely set up there. I just need to insert my numbers. So something that divides 35 and also divides 90. That's what I'm thinking about. So I'm going to pause the video here. You can pause it on your end as well. Just take some time. If you want to work through this, pause the video and consider what those numbers might be. Okay, so hopefully you've come to the conclusion that 5 is something you can divide out of 35 and 90. And that's good. So I can say, okay, I know I can take a 5 out of each of those terms. And 35 divided by 5, that's going to give me 7. And 90 divided by 5 is going to give me 18. Now we haven't dealt with all those x's yet, so we're going to have to figure that out. You may have known that just by looking at the answers, right? There's a 7 and an 18 and a 5, so you may have been able to figure it out from that. We're also, I noticed there's at least one x in each of these. So I'm going to divide an x out of this x squared, and I'm going to divide an x out of this 90x. So if I divide this x out, it's totally gone. And if I divide one of these x's out, I'm left with just 1 here. So what I've done is I've divided a 5 out of here and here, and I've divided an x out of here and here. So I've basically kind of like divided those right out. Okay, so that would mean that our correct answer is our two factors are 5x, and so I don't know, we can pick our side, but let's say this one's going to be 5x. And this side up here will be our 7x plus 18. Cool. So those are our two dimensions when we're factored fully. I mean, a little artificial to throw a picture frame in there, but you get the idea. Often we'll get rectangular things like this. So here's another question that another student asked, pretty similar. The area of a classroom door is represented by the equation A equals 36z squared plus 3600z. Now, realistically, doors are probably more made by like building spec regulations, but we're going to use this as kind of a simplified example. When the expression is factored fully, the factors are the dimensions of the door. What are the actual height and width of the door if z equals 5 centimeters? So we're going to factor first. Right, and then we can plug in for z and see what we've got. So we're dealing with a door here, so it's going to look a little something like that. There's our door. So we want, again, we know our area is length times width, so we got to break this down into one thing times another thing. What are our length and width going to be? So let's get our black pen here, and we'll go, all right, 36 z squared plus 3600. We got to figure out what divides both of those evenly. I think I'll actually put this down lower so I get a bit more room to work with. Let's put it right here. Okay, so we say, all right, we're going to divide something out of those. And I notice there's a plus in between them, so I can put a plus here as well, right? Something that divides both of those. Now, there are a bunch of things that divide both 36 and 3600, but 36 is the biggest one, right? 36 is the biggest possible one for this, and it divides this. So we say, okay, I know I can divide 36, so I'm going to have a 1 here. I'm not going to write that. Oh, sorry, I missed a thing, didn't I? Let's see if I can move this over if it's attached. I need to add a z here. You were probably screaming that into your computer. Okay. There we go. All right. So I notice I can pull a 36 out of both of these. That's going to leave me with a 1 here. I'm not going to write that right now. And that's going to leave me with a 100 here, if I divide 36 out of both of those. But I can also divide a z out of both of them. I can get at least one z from each of them. So I'll divide out a z. That's going to leave me with one z. So I'm just going to write that as z plus 100. So again, I say, all right, I pull the 36z out of here. If I want to check my work to see if it's correct, which is always a good idea, I can go the other way. I can say 36z times z is 36z squared. Yeah, that's what we got over here. 36z times 100 is 3600z, which is what we have right here. So it looks like my dimensions are going to be, on one side, we know it's going to be 100. And on another side, we know it's going to be 36z. Now, I might have picked the wrong one for length and width. We'll have to find that out by substituting in. So we said, okay, what happens when z equals 5, right? So let's do that up here. We're going to say 36 times 5. Sorry about that, folks. I had a little 6-year-old come to visit and tell me he wants to use my drawing pad. So I'm going to start over. Because it is pretty fun, let me tell you, it is pretty fun. So 36 times z is going to equal 5. That's going to be 180. So I did choose the right ones. So this side is going to be 180. So I can get rid of this. And I'll put in a 180 over here. That's going to be 180. So those are my dimensions. So 180 times 100. No, that's not one of my options, is it? Oh, I know what I did wrong. This is not 100. This is z plus 100. You're probably screaming that into your computer as well. Z plus 100. So z plus 100. Z is 5, so this is going to be 105. So 105 on this side, 180 on that side. Okay, so we say, yeah, 180 by 105 is the one we want. So hopefully that that made sense. Use similar to the last one, but it's got this little extra. We got to sub in a value. Okay, so all done on that one. Let's try one more. Here we go, very similar one. The area of a rectangular grass field is represented by the equation 90y squared plus 300y. When the expression is factored fully, the factors are dimensions of the field. What are the actual dimensions if the field is y equals 2 meters? So these sorts of ones seem to be the common questions that I got. So hopefully this is helping a lot of you to see how those are done. I'm going to whip through this one kind of quick because you've already seen me do a very similar one a moment ago. So I'm not even going to draw a picture this time. I'm just going to go 90y squared plus 300y. So we're going to factor this. So we're going to, I notice it's a plus, right? So I'm going to have a plus in here as well. What can I divide out of both of these? I can take a y out of both of them. So I can put that there. I was before doing the number first, but you can do it in any order. And then I say, okay, well, what divides these ones evenly? 30 would divide both of these evenly. So that's a possibility. I can think that I can factor out 30 out of here. Yeah, and it looks like that's the most I can get out of there. So we'll go, okay, 30. So 90 divided by 30 is 3, and y squared divided by y is just y. 300 divided by 30 is 10, and y divided by y is just 1, so that y is all gone. So here's our two dimensions of our field, 30y and 3y plus 10. So in order to figure this out, I'm going to substitute y equals 2 in for each of these. So if I substitute y equals 2 in for my first one, 30 times 2, that's going to be 60, which I see right here. And then if I substitute a 2 in here, I've got 2 times 3 is 6, plus 10 is 16, and I see that right here. So it looks like that's going to be my answer for this one. Okay, so hopefully that's helped you with those types of questions. I'm going to go a little further onto stuff from 2.3 now. So with 2.3, we're taking one step further. We're used to looking at situations like this, and we're using FOIL, right? So we say, okay, first, outside, inside, last. We say multiply x times x, that's x squared, multiply x times -1, that's -1x, 4 times x, that's 4x, and 4 times -1, that's -4. We multiply those out, we collect our like terms, and we end up with this expression right here. Our goal, though, is not to expand, because we're pretty good with that. Our goal is to factor. We want to go backwards and go the other direction. So we're going to have to figure out how we can do that. What's a method where we can come up with some clues that will help us figure that out? And so I'm going to show you a way to do that. You should have watched the videos I posted for this week. We'll just close that. You should have watched the videos I posted for this week already, because those will help you and cover all of this stuff. But we'll go through a few examples in order to give you a little bit more support. So here's one that says factor fully. So here are the things I'm looking for when I'm factoring. I'm looking at this coefficient in front of the variable here in the middle, and I'm looking at this one here at the end. Now, I notice that when I'm going to go back a page here. I notice that when I am foiling this out, let's write out the whole thing, right? We'll go x times x is x squared. X times -1 is -1x. We'll just write that as -x. 4 times x is positive 4x. And 4 times -1 is -4. Now you'll notice I multiplied the 4 and the -1, and that gave me the number on the end here. The stuff in the middle are like terms, so I'm going to collect my like terms. So I've got x squared. I'm going to combine them. I'm going to add those together. I've got -x and plus 4x. That leaves me with positive 3x minus 4. So the thing we want to pay attention to is that the 4 and the 1, those two numbers in there, multiplied to give us this number right here. And the x times -1 and the 4 times x gave us these numbers in the middle, which we combined to get this one right here. So 4 and 1 and -1 multiply to this here, and 4 and -1 add to the coefficient of this one right here. 4 and -1, when you add those two numbers together, you get 3. 4 and -1, when you multiply them, you get -4. So we're looking for, when we're doing this the other direction, we're looking for two numbers that multiply to this and add to this number, the 3, the coefficient in front. So that's going to be the game we're going to play when we're factoring. So here's what we're looking for. We're looking for two numbers that are going to multiply to be 7, and two numbers that are going to add to be 8. So I'm going to make a little table for myself and come up with some numbers here. It'll also probably help me if I actually write this out. So I'm going to put the brackets here like this and like this. And I know this is going to turn out, I'm going to have a B and a B. I also know that it's going to be B plus something and B plus something, because both of these are positive, right? So that tells me it's got to be two positive numbers. Okay. So here we go. Let's see. Let's try and look at the 7, because that's always the key right here. Two numbers that multiply to 7. Let's come up with two numbers that multiply to 7. Two numbers that multiply to 7. 1 and 7 multiply to 7. And that's it. Now, those numbers, fortunately, 1 and 7, also add to 8. So it looks like those are our numbers. Nice and simple. So we're going to have, you can put them in either order. I'm going to put the 1 here and the 7 here. But now we factored this. And if you actually FOIL this out, b times b is b squared, b times 7 is 7b, 1 times b is 1b, 1 times 7 is 7, and then collect your like terms, you're going to end up with this again. So we said they got to multiply to 7. What are some numbers that multiply to 7? 1 and 7. Those are the only ones, because 7 is what we call a prime number. So it's got to be 1 and 7. Let's try our next one. Here we go. Okay, so we're looking for two numbers that are going to add to that and multiply to that. Notice the negative right here, negative 12. So we need numbers that are going to multiply to negative 12 and two numbers that are going to add to positive 4. Oops, that's a little bit curvy. Let's see if I can do better. There we go. Okay. So the multiplying is always easier to try and figure out. So two numbers that are going to multiply to negative 12. Oh, I notice it's a negative, and we know we only get a negative number when we're multiplying if we have a negative times a positive. So I think it's got to be, one of them's got to be a negative number. So I'm just going to pick the numbers, and then we'll think about the negatives later, because the negative could be, it might be on either one of them. I'm not sure which one. So 1 and 12 multiplied to 12. 2 and 6 multiplied to 12. 3 and 4 multiplied to 12. And that's it. So to any combination of these, when I stick a negative on one of them, add to 4. Let's see. So it's got to be a positive. So the bigger number would have to be the positive one. So if I had, say, negative 1 and 12, that would add to 11, positive 11. So that's no good. That doesn't add to 4. What if I had negative 2 and 6? Oh, that adds to 4. Good. So that must be it. So let's draw this in. We know we got to have an n here and an n here, and we're going to have a minus 2 and a plus 6. So our two numbers, negative 2 and positive 6, multiply to be negative 12, and they add to positive 4. And you add those two numbers together. And if we FOIL all this out, we'll get back to where we started. Here's another example. Okay, let's see if we can do this in kind of a bit of a quicker fashion here. So I'm just going to put my brackets around it. I'm going to say I know I start with a here and a here, not squared, right? We get the squared from multiplying them together. I notice it's a plus and plus, so I think it's going to be a plus here and a plus here. It's got to be. Two numbers that multiply to 18 and add to 11. Let's see if we can just come up with those kind of more quickly. 1 and 18, 9 and 2, 9 and 2 multiply to 18. Oh, and 9 and 2 add to 11. So I did it kind of more quickly there. We can put the 2 and the 9 in either spot. But 2 and 9 multiply to 18, and they add to positive 11. So positive 2, positive 9 are going to be our numbers. Let's do one more. Oh, looks like we got the same one. Okay, looks like I don't have any more. So I guess that's it. That's where we're going to stop. So we're going to get into slightly more complicated ones where we've got a coefficient, a number in front of our squared term, when we move on to section 2.4. But that'll be for next week. So for this week, this is as far as we need to go. I hope this has been helpful. Good luck with your work, folks. Make sure to send me a message on Edsby if you're having any problems. I hope it's going well. And remember to submit questions, just like the other students who did this week. The best thing to do is take a screenshot, send it to me on Edsby, and I'll add it into a thing. Now, usually what I do is every Tuesday, I'll go through these questions. Since we started late this week, I'm putting it up on Wednesday night, but usually Tuesday nights. I'll take any questions that have been submitted up to midday on Tuesday, and I can do a video of those. Of course, you can catch me tomorrow morning in our tutorial at 9:30. We can chat then, and I can go through some more problems live where you can ask them, and I'll just go through them on the spot. I hope this has been helpful. Good luck. Talk to you soon.